So I'll share my screen. Okay, I hope my screen is visible to you. So today we are going to discuss about decision trees. Okay, so we'll discuss about the basic concepts about decision tree, how to create this decision tree, and how it helps in decision, how it helps you to classify the data. Okay, so that example also we can discuss, and also basic concepts of entropy. Basic concepts of entropy in information theory, and mathematical formulation of entropy. What do you mean by this entropy? And calculation of entropy of a training set. Okay, so all these things we'll discuss, because based on this calculation only these decision trees are created. And then decision tree induction algorithms. There are different variations in decision tree, like ID3, CART, C4.5, C5.0. So like that, different variations are there. Okay, so that also we'll discuss. So what is a decision tree is, so this decision tree is an important data structure known to solve many computational problems. Okay, so now you are seeing an example. Here you have three attributes A, B and C. Okay, and here this is binary decision tree. Okay, so here actually um, because the values you have are binary values, either 0 or 1. So this attributes A as well as B as well as C, they contain only binary values. Okay, so this type of decision trees, we just call it as binary decision trees. Okay, so based on that, this F value, okay, so M0, M1, M2, etc. So this has been decided. Okay, see here, if A is 0, okay, first we are checking whether A, okay, is 0 or 1. If it is 0, then we are checking whether B is 0 or 1. Okay, and if B is also 0, then we are checking whether C is 0 or 1. If it is 0, that is M naught, otherwise it is M1. Okay, but at the same time, if B is 1, then we are checking for C. So here if it is 0, it is M2, and if it is 1, that is M3. Okay, so like that we are just categorizing, classifying. But the main thing is how to create this tree. Okay, so how to choose the root node, and how to choose the that is subtrees. Okay, root in the subtrees. So that has to be created, that has to be done properly. Okay, so we'll see how to do that. And another example, so in the previous example what we have seen, so in that case the decision tree where values of any attribute is only binary. Okay, but at the same time, decision tree is also possible where attributes are of continuous data type. So in that case, see this example. In this example, here we are seeing decision tree with numeric data. Okay, you can have values also. Here assume that again we have three attributes. Okay, so again assume that we have three attributes A, B and C. Okay, we have three attributes A, B and C, and these three attributes have some values. Okay, these three attributes have some values. Okay, so here actually when you see here, so we wanted to check what the final result we wanted to see is which is greater or lesser. Okay, so this is a very simple example. So the root node is actually what we are checking, whether this A is less than B or not. If it is true, then we are checking whether, so here actually A is less than B. Okay, so this is true. Then we are checking whether B is less than C. If it is true, in that case B lies between A and C. So like that we are deciding. Okay. So in this example, actually the attributes A, B and C has that is numeric values. Okay, so continuous values. And please note down the characteristics of decision trees. Okay, so decision tree may be an n-ary. Okay, maybe n-ary. That means normally we say binary, right? What do you mean by binary? In that case, okay, when you say binary, that means, what do you mean by binary trees? So normally you will have only two children. Okay, if a particular tree contains that is, if the node contains two children, only two children, in that case we say it is binary. Okay, so here it is n-ary, and this n can be greater than or equal to 2. That means any that is, any node can have more than two children. That is possible. Okay, and there is a special node called root node that we all know, right? So this is the root node. And all nodes drawn with circle, that is ellipse, okay, are called in nodes. Okay, so this ellipse, this nodes, no, so this nodes we call it as in node. All the nodes which are drawn using the rectangle boxes, okay, so this nodes we call it as terminal nodes or leaf nodes. Okay, so this nodes we call it as terminal nodes or leaf nodes. And the edges of the node represents the outcome for a value. So these are the edges. Okay, so these are the edges which is connecting different nodes, and this edges, this represent the outcome for a value of the node. Okay, and in a path, a node with same same label is never repeated. Okay, and then, so in the path, okay, you may think that here also height, here also height. Okay, but the thing is, in the path, okay, when you traverse, so in the same, that is, in a path, the node the same label is never repeated. And one more thing is, decision tree is not unique, as different ordering of internal nodes can give different decision trees. So you can't say that for a particular problem, this is the decision tree, because for any training set, that is for any data set, you can create more than one decision tree. Okay, you can create more than one decision tree. It is not unique. Okay, you can't say that this is the only decision tree you can create from a particular data. Okay, so you can have it is, so it is not unique. Okay, you can have different ordering of internal nodes, so that can give you different decision trees. Okay, so these are all some of the properties. And decision trees helps us to classify data. And when you talk about the internal nodes, so this internal nodes represents attributes. Okay, so these are all some attributes. Okay, so internal nodes are attributes. And edges are the values of the attributes. Okay, edges. Okay, so edges are the values of the attributes. And the external nodes are the outcome of the classification. So this leaf node, no, so that is the outcome of the classification. Such a classification is in fact made by posing questions starting from the root node to each terminal node. We know that this rectangle box represents the leaf node or the terminal node. Okay, so here, okay, so when you pose questions and based on the answers you receive, you will come to a conclusion what is the class. Okay, and the decision tree consists of nodes. So what's a node? Test for the value of certain attribute. And edges, it corresponds to the outcome of the test. Connect to the next node or leaf node. And actually, what is leaf nodes? Those are the terminal nodes that actually predict the outcome. Okay. See here. See this diagram. In decision tree learning, a new example is classified by submitting it to a series of tests that determine the class label of the example. These tests are organized in a hierarchical structure called a decision tree. So for example, already you have some set of training data. Okay, so assume that this is your training data, and using this training data, okay, you have created this decision tree. You have formed this. Decision tree. Okay, and based on that, you have to classify whether it is green or yellow or red or green, something like that. You have to classify. So this is the decision tree model that you have created from the sample data set. Okay, but after training, when new example comes, okay, when new example is fed into this decision tree, it has to say that what class it belongs to, okay, what class it belongs to. So the training examples are used for choosing the appropriate test in the decision tree, and typically a tree is built from top to bottom, where tests that maximize the information gain about the classification are selected first. So we'll see how to create this decision tree. So as I have told you, the strategy used in decision trees are top-down approach. So recursive divide and conquer fashion. So in this fashion it works. And first select the attribute for the root node. What is the first step you have to do? You have to choose the attribute for the root node. We'll see how to choose this. So create branches for each possible attribute value. Then split the instances into subsets, one for each branch extending from the node. Finally, you repeat this process recursively for each branch using only one instance that is the branch. So what is the stopping criteria? You can stop if all the instances have the same classes. Okay, if all the instances have the same classes, in that case you can stop. So that is the stopping criteria. So as I have told you, this is the root node and these are the decision nodes, okay, and these are the terminal nodes. So the leaf nodes, we call it as terminal nodes. So a decision tree is a classification and prediction tool having a tree-like structure where each internal node denotes a set of attributes and each branches represents an outcome of the test and each leaf node or the terminal node holds the class label. Got it? So we are talking about root node, decision node and terminal node. Okay. So this internal node, it denotes the attribute. Okay. And each branches represent the outcome of the test. Please note down these important terms because based on this only we are going to create the decision tree. The first one is entropy. Okay, the first one is entropy. So in machine learning, entropy is a measure of randomness. What is entropy? Entropy is a measure of randomness in the information being processed. Higher the entropy, the harder is to draw any conclusion. Okay, that means it is random. Okay, you cannot come to a conclusion. So entropy should be minimum. So how to calculate that entropy? H of x is equal to minus summation of 1 to n p of xi into log p of xi. Okay. So this is the formula for calculating the entropy. And next important term is called information gain. So what is this information gain? This information gain can be defined as the amount of information gained about a random variable or a signal from observing another random variable. Okay. So what is it? It is the amount of information gained about a random variable or a signal from observing another random variable. And it can be considered as the difference between the entropy of the parent node and the weighted average entropy of the child nodes. Got it? So how to calculate this information gain? So assume that this is the parent node, okay, and this parent node has 3 children. Assume that this parent node has 3 children, okay. So assume that P is the parent node and you have 3 children A, B and C, okay. So this parent node contains 3 nodes, okay, that is A, B and C. How to calculate this information gain? So you have to calculate the entropy of the parent node. Okay, calculate the entropy of the parent node. And then you have to calculate the entropy of the child nodes. Okay, so that is actually you have to calculate the average entropy. So it is the summation of entropy of A, B and C. So that entropy you have to calculate. And then you have to calculate the difference between the entropy of the parent and the children, and this will give you the information, okay, about a particular node. So what's the formula? information gain of S comma A is equal to, okay, H of S minus H of S comma A. Okay. So here actually this is the entropy of parent node and this is the entropy of the child node. So alternatively you can represent like this also, that is Hs minus, okay, summation of 0 or summation of I is equal to 1 to n P of x into H of x. Another important mathematical term, kindly note it down. So that is called Gini index. Okay, that is called Gini index. So this Gini impurity is a measure of how often a randomly chosen element from the set would be incorrectly labeled if it was randomly labeled according to the distribution of labels in the subset. So this Gini, this particular metric is used to check the purity. Okay, it is used to check the purity. So how to calculate that? G of E is equal to 1 minus summation of J is equal to 1 to C, okay, P of, so Pj the whole square. So this is how we calculate the Gini index, okay. So this Gini impurity is lower bounded by 0, with 0 occurring if the data set contains only one class, okay. Otherwise, this value will be increasing. So as I have already told you, there are different types of decision trees. There are many variations in the decision trees and few things we are going to see now. So there are many algorithms that to build a decision tree. They are CART. What is CART? Classification and regression trees. Okay, so that is called CART. And this makes use of Gini impurity as the matrix. So for generating the decision tree, this CART, it uses the Gini impurity. At the same time, okay, another variation is that is called ID3. Okay, ID3. So that is also called as iterative dichotomizer. Okay, iterative dichotomizer 3. And this uses the entropy and information gain as a metric. Okay, so this uses the entropy and the information gain as the metric. Now we'll see an example so that you can easily understand how to create a decision tree. So all of you please take your notebook and try to note all the steps. Okay, please take your notebook and try to note all the steps. So here we have an example. That is, this example already I have shown you in the regression also, the same example. So we have four attributes. What are they? Outlook, temperature, humidity, and wind. So in this example, we have four attributes: outlook, temperature, humidity, and wind. So these are the four attributes. And what was the label you wanted to classify? In this particular environment, will a particular player will play football or not? So the class labels are either yes or no. Okay, so based on this condition, it has to say that whether they will play or not. So here there are four independent variables to determine the dependent variables. So these are all independent variables. Okay, so this outlook, temperature, humidity, all these things we call it as independent variables. The independent variables are outlook, temperature, humidity, and wind. The dependent variable is whether to play football or not. Okay, so the dependent variable is whether to play football or not. So how to decide? Okay, how to make a decision? So based on the values, based on the environment, based on the outlook, based on the temperature. Okay, so already when you see here, so based on the training data which is available, already this decision tree will be formed. So when you give a new value to this decision tree, it can process it and it can give you what is the decision that you need to take. So in this example, the root node, which is the root node outlook. So when you see the values of outlook, there are three possible ways for outlook: sunny, overcast, and rain. Okay, so three possible values for outlook. So sunny, overcast, as well as rain. Okay, so here you have three attributes. Okay, sunny, overcast, rain. And the next attribute is humidity. So if it is sunny, then you just check for humidity. And if it is normal, in that case, okay, you have to say what will be the value. And similarly, based on this value, you can say whether it is yes or no. Okay, fine. You can decide, okay, whether, yeah, the players will play or not. So that decision you can take it very simply. So to understand this, you should know all the mathematical formula for calculating this. Please note down the steps. Now we are going to see how we are going to classify using ID3. So what's the first step? Find the parent node for our decision tree. Okay. So first you identify a parent node. And then what you have to do, you have to calculate the entropy. Okay. So find the entropy of the class variable. The first step is you have to find the parent node. So for that, what you have to do, you have to find the entropy of the class variable. So what are the two class variables in our example? Only two class variables. Please note down this training data. I give you 5 minutes, not 5 minutes. 1 minute is enough, I think. Okay. So please note down this table. Please note down this table. From based on this only we are working it out. Kindly note it down. Randomly I'll ask questions. Please note it down. I'll give you 1 minute. Please note down this. Based on that only we are going to work it out. Have you noted? Have you noted? So what are the two classes? Yes and no. And how many training data are there? Totally, actually, we have 3, 5, 6, 14 training data are there, right? 14 training data are there. I hope you might have taken this because in the later part, actually, we are going to explain this algorithm using this data only. So please kindly note it down. Okay. Now we'll see how to calculate the entropy. Okay, we'll see how to calculate the entropy. Okay, first what we have taken is we are going to calculate the entropy for the class variable yes or no. Okay, for the class variable yes or no. And we are taking one attribute. Okay, we are taking one attribute, that is the outlook. How many values it is having? Either it is sunny, overcast, or rainy. So whether they will play yes or no, actually, so under sunny you can see that, okay, under sunny you can see that, so 3 yes, okay, and 2 no. Got it? Under overcast, you can see that 4 yes. You just go through that training data, that is sample data, and 0 no. And for rainy, actually 2 yes and 3 no data. Okay, so how many totally? 5, 14. Okay, so 14 that is 14 training data are there. Okay, and under sunny the total is 5, this is 4, and this is 5. Okay, now how to calculate the average weighted entropy? Okay, so how to calculate the, see, for example, if I wanted to calculate the entropy for outlook, then I have to calculate the average entropy of its all children. Okay, because it has three values, no, sunny, overcast, and rainy. For example, if you take this outlook as the node, okay, if you take outlook as the node, Okay, in that case, actually the values you may get is either sunny or outcast or rainy. Okay, so here what we are taking, we are just calculating the entropy of outlook. So that is equal to, okay, 5 by 14, this 5, okay, this total 5 by 14 into entropy of how many s? 3 comma 2. Okay, entropy, that is E of 3 comma 2, that is, this is for sunny, right, plus 4 by 14, okay, plus 4 by 14 into entropy of 4 comma 0 plus this 5, okay, this 5 by 14 into, because this is for rainy, into 2 comma 3. Okay, so this we have to calculate, that is equal to 5 by 14 minus, so what's the formula for calculating this entropy of 3 comma 2? That is 3 by 5, that is this 3 divided by the total 5 into log of 3 by 5 minus 2 by 5. See this formula, don't forget this formula. Okay, this is the entropy, right? So based on that we are just calculating. Okay, based on that we are just calculating this. Okay, so this 5 by 14 and what is this entropy of 3 by 5 minus of, okay, 3 by 5 into log of 3 by 5 minus 2 by 5. Okay, minus 2 by 5 into log of 2 by 5. Okay, plus this term. Okay, so this is 4 by 19, and since 1 0 is coming, no, so automatically when you divide everything it becomes 0, so we have straight away put 0 plus this one. Okay, so 5 by 14 into, we have to calculate the entropy for this. So for that it is 2 by, okay, this 2, right? So 2 by, what is the total? 5. 5 into log of this 2 by 5 minus, okay, minus, the next one is 3 by 5. Okay, so out of 5, how many, yeah, no, we have 3, right? So this is actually how many yes we have, that is 2. Okay, so 3 by 5 into log of 3 by 5. So when you give that, what entropy value we have calculated for outlook, it is 0.639. Okay, it is 0.639. For the, actually now we are calculating the entropy of the class variable yes or no. Okay, so for yes or no, actually now we are calculating. And now what you have to do is, okay, so this entropy we have calculated, right? So here actually, so this is the entropy. What is the entropy of S comma S or no? It is 0.94. Okay, and this is the entropy of outlook. Okay, this is the entropy of outlook. What is the value? That is 0.693. And then find the information gain. So it is the difference between parent entropy and the average weighted entropy. What is information gain? That's the difference between the parent entropy and the child. So this we take, that is initially this class variable, no, the entropy of the class variable that you have to consider. So that you will consider as the parent. So 0.94 minus this entropy 0.639. So you will get 0.247. So that is the information gain of outlook. Got it? I hope you might have understood how we are calculating. Okay. So this is actually the entropy of the class variable S or no. Okay. So in that, how we have calculated, what is this 9? So this 9 is the Okay, sorry, actually I got disconnected. 1 minute. I'll share my screen. Okay, so we were discussing about this, right? Entropy of class variable, yes and no. So here we have to find out how many yes, how many yes, totally 9 yes. Okay, so 9, and what is the total training set? That is 14. So 9 by 14, log of 9 by 14 plus how many no's? That is 5. Okay, so 5 by 14, log of 5 by 14. So this is the entropy of the class variable S and no. Similarly, we are going to calculate for the outlook. So since for outlook, there are three values: sunny, overcast and rainy. So for each one, we are just calculating. Okay, so for each one, for sunny, we are calculating, and then for overcast, and then for rainy. Okay, so these three values we are calculating. So that is equal to 5 by 14 into this V of this 5 by 14. Okay, first one, this one. Okay, so 5 by 14 into this entropy of 3 comma 2, and then it is 4 by 14 into entropy of 4 comma 0. Then this is 5 by 14 into entropy of 2 comma 3. Okay, and how will you calculate the entropy of 3 comma 2? Okay, so 3 comma 2, it is minus 3 by 5 log of 3 by 5 minus 2 by 5 log of 2 by 5. Okay, so like that we have calculated, and this is the value. And how to calculate the information gain? That is the difference between the entropy of the parent. So here initially we have taken that variable S or no. So that as the parent node, and this is the outlook. Okay, so what's the information gain? It is 0.247. And similarly, other four variables are there, no? So outlook we have calculated. Now similarly, you calculate for temperature, humidity as well as windy. Okay. So please try calculating that. We know this is the entropy of the parent class, that is yes or no. Okay. So this we have already calculated, no? So this is the thing. And now for temperature, this is the value, and for humidity, this is the value, and for windy it is 0.8932. So when you apply that, what is the information gain? The information gain is 0.029. So here it is 0.152, and this is 0.48. Okay, 0.048. So which has to be chosen as the root node is, now you select a feature having the largest entropy gain, okay, or information gain. So it is actually outlook. So it forms the first node or the root node as our decision tree. What is the information gain for outlook? So it is actually for outlook it is 0.249, I think, right? Yeah, 47. 0.247. So this is greater than, okay, this is greater than all other three nodes. So you have to choose outlook as the root node. So now outlook becomes the root node. Now what you have to do? You have to choose what is the next sub node or the sub tree. You have to find out the next node. You have to find out. How will you calculate? Now you take this outlook as the parent node. Okay, now you just take outlook as the parent node, and then you just calculate the entropy for all these sub nodes, and you calculate the information gain for all the other attributes. Then based on the information gain value, you just select the next level node. Okay, so here actually, so now when you see here, okay, so outlook, and if it is sunny, overcast, what are the values? So since overcast contains only example class yes, we can set it as yes. That means if outlook is overcast, football will be played. Okay. Now our decision tree looks as follows. See, for example, when you say that is where when you say this outlook, okay, when you take sunny, okay, when you take sunny, So how many yes and how many no? Actually 3 no and 2 yes. But at the same time, when the value for Outlook is overcast, all values are yes. That is, no decision is needed actually, yes or no, no confusion, nothing. All values are yes. So straight away you can write yes here for overcast. Okay. Uh, because in all the scenarios, it is the value is yes only. But at the same time, for temperature, okay, sorry, for rain, it is actually 3 yes and 2 no. Okay, 3 yes and 2 no. So in that you have to explore. Okay. So the second step is you have to find the next node in our decision tree. So what you are going to do? So we are that is find one under sunny. Okay. Determine which of the following, that is temperature, humidity, or wind, has the higher information gain. So you have to calculate. Okay, you have to calculate the yeah, that is, first you calculate the entropy. From entropy you calculate the information gain. So what are the other three attributes? Temperature, humidity, and wind. Okay, whichever is having the higher information gain, that has to be added as the next. So when you calculate, okay, so in this case, the information gain for sunny and temperature is 0.57, and information gain for sunny comma humidity is 0.97, and information gain for sunny comma windy is 0.0. So when you see here, okay, so for sunny, okay, the information yeah, that is for humidity, the information gain is higher. It is 0.971. So this is the largest value. So humidity is the node that comes under sunny. Got it? See here. Now this is your root node, and so under sunny, okay, if the value is sunny, what should be the next node? So either this should be humidity or temperature or wind, but since this humidity is having the highest information gain, you have to add humidity, okay, as the next node. Got it? For overcast, everything is yes, so we have straight away we have note down that as yes. And similarly, the next node is actually wind, right? So all the third step is final decision. So the branch with entropy more than 0 needs further splitting. So not all leaves need to be pure. Sometimes identical instances have different classes. Stop when data cannot be splitted any further. This is how you have to create the decision tree. Okay. So the main advantages are decision trees are super interpretable, require little data pre-processing, suitable for low latency applications. Okay. Some more advantages are it is easy, extremely fast, and models are easy to interpret, accuracy is comparable, okay, and also tree models make no assumptions about the distributions of the underlying data, that is non-parametric, and have a built-in feature selection method that makes them immune to the presence of the useless variables. And the main drawbacks or disadvantages are it is computationally expensive to train, and some decision trees can be overly complex that do not generalize the data well. And one more important thing is less expressivity. So there may be concepts that are hard to learn with the limited decision trees. The main important drawback is actually the problem of overfit. Okay, more likely to overfit the noisy data. If the data is very noisy, automatically it will create an that is data with overfit. So the probability of overfitting or noises increases as the tree gets deeper. Okay, so this is the main disadvantage of decision trees. The remaining things we can discuss in the next class. Thank you. If you have any queries, you can ask me, otherwise you can do.